For elementary students, measurement is a very important math concept, and it's a very broad category. It's also a category that connects very closely to real life, and for this reason it's especially important that elementary students master the skills involved in measurement. In every math concept, it's important to back up to that very beginning understanding. Why does this topic matter? Measurement is a way of helping us human beings organize the world. It's helping to make sense out of things that we do and how we spend our time. Students need to understand that. And when we begin with measurement, we need to make sure that students understand that measurement is a concept that's really quite abstract. It's all about measuring something in comparison to something else. So when we start with measurement with students, it's important to start with things that are non-standard, to get them thinking about why we even have standard measures in the first place. For example, if we ask students to measure something in our room with their shoe size, and we have them all take off a shoe and measure it, they're going to come up with different answers. Just that experience, having them compare, is very important, because then they can look at it and we can say, why do you think we got different answers? If you say that our object is 10 shoes and you say that our object is 15 shoes, how are we going to know what it really is? How are we going to know what the right answer is? And the right answer is, well, it depends on what we're comparing it to. If we're comparing it to this shoe, which is smaller, then that 15 makes sense. If we're comparing it to this shoe, which is bigger, then that 10 makes sense. We need students to understand that they can measure with almost anything. They can measure with paper clips, they can measure with shoes, and we want them to also think about what makes sense in measurement. If we have a large rug in our classroom and we tell them to measure it with paper clips, we want them to shake their head and say, no, that doesn't even make sense. We should measure it with something bigger. So moving from non-standard measures to standard measures is the very beginning, and we want students to think about what measurement is all about and why we have it in the first place. In this video, we're going to talk about some kinds of measurement very generally. The first one we're going to talk about is length. So we need students to understand, what does it mean when we're measuring length? One of the misconceptions that students have is that we're always going to be measuring something that's a straight line. And that's not true. For example, if we picture a path in an anthill, it might curve up and down and all over the place, and we can still measure it, and it's still length. So we need to expose students to different kinds of length. But in all the kinds of length, we do want them to understand that we're just measuring one dimension, length. We start here, we might measure in a straight line, we might measure up and down, we might measure in curves, and we end here, and that's one dimension. It's length. When we start adding labels to our measures, we want to make sure that we include metric and non-metric. We want students to measure in inches and feet and yards and miles. We want students to measure in meters and centimeters and millimeters. We want them to be able to compare those systems so that they know how big a centimeter is compared to how big an inch is. We want them to have a solid understanding of the different systems that we use to measure length. We also want to make sure that students relate those measures to fractions. For example, in the picture here you see a very large inch, and we want students to understand that this inch can be divided into a lot of parts. We've already talked about parts. We've had some experience with fractions. So if we take the inch and we cut it in half, we have this line that shows a half of an inch. But we could cut the half in half again. And if we did that, we would have these lines. Those are each representing half of the half. So if we looked at those lines and we counted 1, 2, 3, 4, that would be 4 equal parts. So we have 1/4, 2/4, 3/4, and 4/4, which is our 1 inch. But we could cut those parts in half again. And if we cut each fourth in half, we have an eighth. So we have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8, which is 1. And on many rulers, we can divide once again. If we divide each one of these in half again, we have our 1/16 of an inch. We can help students understand that a 16th of an inch means we're taking 1 inch and we're dividing it into 16 parts. And then as we look at each of those parts, we have 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, etc., until we get to the end. And then we have 16/16, which is 1. So when students understand that we're using fractions to divide an inch into smaller parts, they see that fractions and measurement are connected. And they can go back and they can look and see that 1/8 is the same as 2/16, or 1/2 is the same as 2/4, 4/8, or 8/16. That has very different names, and this helps them to connect to what they learned about fractions. It also helps them understand measurement, length, inches, which is used in the real world. We can do the same thing, of course, with metrics. We can work with decimeters, centimeters, millimeters, and show the relationship there as well. We also want students to understand that length is what we use when we find perimeter. For example, if I want to know the distance around a garden, the distance around something where there's a fence, that's perimeter. So we can show them that length is used in many different ways. And one of those ways is to measure the distance around something, perimeter. We want students to be able to do all of these measurements, not just see it in a textbook. We can have them easily practice these things in real ways, which is so much more valuable to the student. When we introduce area to students as a kind of measurement, we want to make sure that they understand how it compares to measuring the length of something. When we measure the length of something, we're measuring one dimension. We start at a point, we measure whether it's straight or curved, and we end. We're measuring one dimension, the length. But when we measure the area of something, we're measuring 2 dimensions. We're measuring the length and the height, or the length and the width. We can use different words to describe the 2 dimensions that we're measuring, but we're measuring it in 2 different ways. So if I decide to measure this with squares that are about this big, then I can make a row of squares and I can cover the shape that I have. And it would take 1, 2, 3, 4, 5, 6 of those squares to make one row. So if I continued and I kept covering my unit with shapes that were that size, squares that were that size, and we'll pretend that I'm being more accurate in my drawing here than I really am, but you can get the idea, then I would have 6 of those in each row, and I would have 1, 2, 3, 4, 5, 6 rows. So if these were all exactly the same size, I would have 36 units that would be covering this rectangle. And those units are square. And that's why when we measure in inches for area, we call it square inches or inches squared. We want students to understand that the reason that we're calling it inches squared is because that's what we're measuring with. We're measuring with squares. It should be one of those duh moments where students just say, well, of course it's a square inch. It looks like a square and it's an inch on all sides. And we are measuring this rectangle and covering it with 36 of them. So the area of this rectangle is 36 square inches. We also want to make sure that students are actually doing this measurement, that they're drawing these pictures, or that they're covering the rectangle with squares, actually cutting out squares and covering them. Too often in textbooks, the dimensions of something are already given to a student. So it might say this is 8 inches and this is 6 inches, and then it will ask students for the area. And students then are just calculating. There's no meaning. We also want to make sure that students understand how area is used in real life. So we would look at something like this. We're going to buy carpeting. We're going to buy a nice soft carpeting that's going to feel good on our feet for the bedroom. How much carpeting will we need? Buying carpeting is a very practical application of finding area, which is measuring in 2 dimensions, 2 ways. So we start with measuring 1 dimension, length. We move to 2 dimensions, area. And then we can move to 3 dimensions, which is volume. We want students to know what volume is. The volume means we're filling something. Just like area means we're covering something with square units that are the same size, with volume we're filling something with blocks or cubes that are the same size. So if I take small cubes that are about this big and I fill my shape with them, I'm going to make a row of those cubes. And I might end up with 1, 2, 3, 4, 5, 6, 7 of them in a row. And then I would end up continuing to fill the bottom until I had a solid row of those blocks. And then it would be very easy to count up how many blocks it took me to make that one filled row at the bottom. Then I can figure out how many of those rows going up it would take to completely fill my shape. And I could count up those blocks, and that would tell me the volume. And when I have that number, then I will need a label. What is my label? What did I fill that with? I filled it with these units that are all the same size, and those units are actually cubes. So my answer would be cubic centimeters, or cubic inches, or cubic, whatever the unit is I'm working with. They're cubic because, duh, they look like a cube. That's what we want students to be able to think. And they're cubic because we're actually measuring in 3 dimensions. That's what makes a cube. We can measure in 3 different ways: length, width, and height. And that gives us a 3-dimensional object. We want to make sure that students also then can transfer that idea to shapes that are more unusual. For example, if we look at this cylinder, if we could just figure out what the area of the bottom is, how much it would take to fill up this bottom, then we can say, if we have that bottom repeated as many times as it takes to get to the top, that will tell us the volume of this cylinder, even though it's an unusual shape. That's a much more abstract concept, but it's the same idea as what students can actually do with the blocks. The nice thing about the blocks is they can physically do it. They can fill them. We can give them those materials and they can do it. Then they can transfer that knowledge to something that's a little bit more abstract. And then they can transfer that knowledge to what's happening in the real world. Where do we use this skill in the world? We use it when we talk about mailing packages or filling swimming pools. Volume is used in many places in the world, and students need to see that it's something real. Money is another method of measurement. We're measuring things that we trade, things that have value, things we can use to buy, to purchase, to trade. And money is a tough thing for kids because in some ways it's a bit conceptual and in other ways it's very abstract. So this is something we want to spend a lot of time on when we teach money and teach it very carefully. But when we introduce it as a method of measurement, we want to hit those backing up kinds of ideas. We want them to know, of course, the names of the different kinds of money we use, the coins and the bills. We want them to understand the relationships. For example, 10 pennies equals 1 dime. And for many young students, this isn't logical. There are so many of these pennies, and the pennies are actually bigger than the dime. So we need to teach that carefully. How many pennies are in a nickel? How many pennies are in a dime? How many pennies are in a quarter? How many dimes and nickels are in a quarter? Same thing with bills. These bills look very similar. They have different pictures on them, and they have different numbers on them. Those 2 bills, a 5 and a 5, make a 10. So again, we have digits and number meaning here, and we also have some conceptual, some base 10 ideas, such as 10 pennies in a dime. We write money in base 10. If we say that we have $13.15, we're writing in base 10. That means we have $13, a 10, and 5 hundredths. But in this case, the 5 are pennies because there's 100 pennies in a dollar. This is all about place value again. So we need to make sure and make those connections and make them intentionally. Money, working with money, is very real, but it's also very abstract, and that makes it a very difficult concept for kids to understand. Often we think it should be easy for them because it's practical, it's out in the world, they see it. But in actuality, the system of money is not easy. It's complicated. We need to teach it carefully. Another thing that we measure in the world is time. And this is another thing that we sometimes think of as being very simple. I go into classrooms and I see very young students working with worksheets that have clocks, and they're putting in the hands to set it at certain times. But in actuality, time is very complex, and we need to back up and give students that complex, critical thinking sort of background to what time is. It's an artificial system that somebody created that helps us measure our life and how it happens and when things happen. We measure time in years, months, days, and even in our day, we have day and night, we have AM and PM, and within those days we have hours, minutes, seconds, and even fractions of a second. We need to have students understand that time is moving, it's not standing still. This can be done by having students watch a clock. We can have them tick away and count the seconds. We can ask them to sit quietly for 1 minute. We can ask them to measure things. How many of these things can we do in a minute, so that they understand that time is moving? Working with stopwatches is another thing that very young students love to do. Let's all stand up and do 10 jumping jacks, and let's count. We'll start our stopwatches and we'll see how many seconds it takes us to do 10 jumping jacks. Again, we're measuring the moving part of time. We also want to make sure that students know about all the different ways that we've measured time over the past and currently. We want to make sure that they understand what a sundial is and how early populations use that to measure time, or an hourglass where sand fell through to measure time. We want to make sure that students know the different kinds of clocks that we use today. We have clocks that are based on 12 hours, even though there are 24 hours in a day. And we can teach them that we're splitting our day into 2 parts. 12 hours of daytime, 12 hours of nighttime. And we can have students actually follow time so that they know that that time is passing. We can also show them clocks that are 24-hour clocks. These might be used in military time or by firefighters. Both of these types of clocks are analog clocks, and students often don't know how to read these kind of clocks easily. They're so used to digital clocks in today's world. They see them everywhere. So we need to make sure that we teach analog clocks very carefully, because it's a very abstract idea. The fact that we would have clocks where time moves in a circle, a second, a minute, an hour, 12 hours, 24 hours, and those hands are constantly moving. We can also connect fractions to analog clocks. We can talk about a quarter of an hour or a half an hour, or we might say that a time is a quarter to an hour or a quarter after an hour. We might talk about a time being half past. There are so many mathematical concepts that are connected to time, and we need to make sure that students understand them all. We have liquid measurements in our world as well. And one of the most common things that we use liquid measurements for is cooking. We also use liquid measurements for measuring medicine or other scientific things. When we teach liquid measurements, we want to make sure that we're teaching both standard and metric, and that we're teaching students real ways that these are used in the world. Sometimes we can even teach students tricks to help them remember things. For example, if I had students draw this with me, make a square, and we'll call it the body of a person. Give this person a head, give them 2 arms and 2 legs. On each arm, we're going to make kind of a funny looking hand, and on each leg, we're going to make kind of a funny looking foot. And on each hand, we're going to give them 4 fingers, and on each foot, we're going to give them 4 toes. And then we're going to take a look at what we have here, and we're going to say, what if this were 1 gallon? That would mean that each one of our arms and legs is 1 quart, because there are 4 quarts in a gallon. And each one of our funny-looking hands and feet is 1 pint, because there are 2 pints in a quart, which means there would be 8 pints in our gallon. And each one of our little fingers and our little toes is 1 cup. So by looking at our gallon person, we know that there are 2 cups in every pint, 2 pints in every quart, 4 quarts in each gallon, and then we can look at our gallon and we can figure out how many cups would be in a gallon or how many pints would be in a gallon by just counting up how many are attached. This makes a nice little trick to help students remember the relationship between these things, which can be very difficult for them if they just memorize. We can also have students give this person a face and hair and a name. They can call this person Mr. Gallon, Mrs. Gallon, Miss Gallon, Kid Gallon. They could give him an actual name and call him John Gallon Smith, whatever they want, just for fun. The purpose of this video is just to introduce and help us remember that measurement is a very big topic. There are so many things that we measure in the world. They help us organize our world, and we need to make sure that we teach students how those different kinds of measurement are related. We need to make sure that students are doing the measurement with real things and doing it often, not just looking at pictures of things being measured in a textbook. We need to make sure that we teach why we're measuring, because we are organizing our life and standardizing things so others can understand what we're talking about, so we have the same picture, the same understanding. We need to have students understand that measurement is real, but the systems that we use to measure are often very abstract. They were just created by human beings to be able to help us measure something. Measurement is a practical life skill, and too often I believe that it's neglected in schools. When I ask teachers about that, they will often tell me that they have to spend so much time on computation, multiplication, division, fractions, decimals, and on what is being tested by standardized tests, that they don't have time to teach these kinds of concepts. Measurement is a practical skill. It's a life skill. It's something all students should know how to do, and we need to make sure that we take the time to teach it well.